Okay, in this video for the stoichiometry practice problems, we are going to be doing 3, 4, and 5. So, notice if you start with 20 grams of hydrochloric acid, how many grams of sulfuric acid will be produced? First thing before you start anything for this one, notice that this is not balanced. So, there's one hydrogen here, there's 2 on this side. We're going to multiply that by 2. That means there's 2 chlorines now. That means I need to multiply this by 2. That gives us 2 sodiums, so 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines, 2 sodiums, and 1 sulfate. So now it's balanced. We're starting off with 20 grams of HCl, and how many grams of hydrochloric acid are going to be produced? So, in order to go from one compound to another compound, you have to get it in moles first. So that means we need to go grams to moles of HCl before we do anything else. In order to do that, you have to find the molar mass of HCl. That's 1 hydrogen and 1 chlorine. You can look on the periodic table and find the hydrogen is 1.01 and chlorine is 35.45. 1 times 1.01 and 1 times 35.45. Now we have to add those two numbers together. And that comes out to be 36.46 grams of HCl is equal to 1 mole HCl. Now that we have what we need to get into moles of HCl, we need to go from moles of one to moles of another. In order to do that, we're going to be using the coefficients. There are no conversion factors for that because we're going to be using the big numbers in front that we use to balance the equation. And then we want to go to moles of H2SO4 into grams. In order to do that, we will need the molar mass of H2SO4, which means we have hydrogen, sulfur, and oxygen. We have 2 hydrogens at 1.01. We have 1 sulfur at 32.07, and we have 4 oxygen at 16.00. We're going to add those 3 numbers up, and that comes out to be 98.09 grams per mole of H2SO4. Alright, now that we have all the conversion factors we need for the entire problem, we can actually start doing the conversion itself. That means the number that we're starting with, which is where our arrows start with, is going to go over 1 to turn that into a fraction. All I've done is put it over 1. The value is the same. I just changed it into fractions so that way we can multiply and divide by fractions. So we have grams of HCl on the top. That means I want grams of HCl on the bottom of the next one. If we look at go from grams to moles, we use the molar mass of HCl, which we calculated right here. Here's the grams of HCl right here. That 36.46 is on the same side as the equal sign of the grams of HCl. That way, that means that those two things are going to go together. And then 1 mole of HCl is going to go on top. Now we have moles of HCl on the top. We want to put moles of HCl on the bottom of the next one. We are right here now in our problem. We need to get from here to here. To do that, we're going to use the coefficients. So if you look at HCl, the coefficient is 2. And we're going to H2SO4, so moles H2SO4, and the coefficient there is 1. Notice that where we're coming from is always going to be on the bottom. Where we're going to is always going to be on top. Moles of H2SO4 on the top, moles of H2SO4 on the bottom, the next one. in order to get from moles of H2SO4 to grams of H2SO4, we're going to be using the molar mass, which is right here that we calculated. 98.09 grams per mole. That means it's equal to 1 mole. So 1 mole H2SO4, that is equal to 98.09 grams H2SO4. We have it all set up now. We had to put it on the calculator. We'll start from the left to the right. 20 grams go into our calculator. If it's on the bottom, we divide. If it's on the top, we multiply. So 20 divided by 36.46 divided by 2 times 98.09. And that should come out to be 26.9 grams of H2SO4. But if you notice in our initial question, you only have one significant figure there. That means I'm going to round it up to 30. Okay, number 4. I began a reaction with 20 grams of lithium hydroxide. What is my theoretical yield of lithium chloride? So I'm looking for, when it says theoretical yield, they're asking for how many grams. The equation's already balanced, so we don't have to worry about this. In order to get from one compound to another, though, I need to get it into moles first. So to get from grams to moles of LiOH, that means I need the molar mass of LiOH. So we have Li, O, and H. We have one lithium at 6.94. We have one oxygen at 16.00. And we have one hydrogen at 1.01. We're going to add those three numbers up. And that's going to equal 23.95 grams of lithium hydroxide is equal to 1 mole lithium hydroxide. Now that we're in moles of lithium hydroxide, we need to get moles of lithium chloride. To do that, we need the coefficients. Now we're in moles of lithium chloride. It's asking about grams of lithium chloride. So therefore, we need to figure out the molar mass of lithium chloride. So we have lithium, we have chlorine. Lithium, we have 1 at 6.94. And we have 1 at 35.45. Add them together to get the molar mass, and that comes out to be 42.39. So that means 42.39 grams of lithium chloride is equal to 1 mole lithium chloride. Alright, so now that we have all the conversion factors we need in order to do the question, we're going to start from the beginning. We're starting with 20 grams of lithium hydroxide. Notice that's also the number that's actually given to you in the question itself. We have grams of lithium hydroxide on the top, so we're going to put grams of lithium hydroxide on the bottom of the next one. Here's grams of lithium hydroxide. 23.95 grams goes together with the grams of lithium hydroxide, and that is equal to 1 mole lithium hydroxide. Now we have moles of lithium hydroxide on the top. That means I want moles of lithium hydroxide on the bottom of the next one. We are right here in our plan right now. So we need to go from lithium hydroxide over to lithium chloride. So we use the coefficients, which there are none, which means that it's 1. So where we're going to is lithium chloride, so 1 mole of lithium chloride, because the coefficient is 1. Now that we're in moles of lithium chloride, we can get back into grams of lithium chloride. Moles of lithium chloride on top, put moles of lithium chloride on the bottom. 1 goes with moles. That means that is equal to 42.39 grams of lithium chloride. So it's 20 divided by 23.95 because it's on the bottom, times 1 divided by 1, then times 42.39 because that's on the top. So that comes out to be 35.4 grams of lithium chloride. or if you round it up, it's 40 grams of lithium chloride. The reason why you might want to round it up is because of significant figures. Okay, we are finishing up this video with number 3. Notice, before we even start, this is not balanced. So we can go ahead and balance that before we do anything else. We have 3 carbons. That means I'm going to multiply that by 3. We have 8 hydrogen, so I'm going to multiply that by 4 to make 8. So that means we have 6 oxygens here and 4 more here. So that means we have 10 oxygens total, which means that we need 5 O2s to make that balance out. Alright, if I start with 5 grams of C3H8, what's my theoretical yield of water? So, in order to get from C3H8 over to water, I have to get it into moles first. So I need to go to grams to moles. And by doing that, I'm going to use the molar mass of C3H8. So that means I have carbon and hydrogen. I have 3 carbons at 12.01, and I found that off of the periodic table. That comes out to be 36.03. And I have 8 hydrogens at 1.01. That comes out to be 8.08. I found that off the periodic table. I'm going to add those together, and it comes out to be 44.11 grams of C3H8 is equal to 1 mole C3H8. Now that we're in moles, we can go from one compound to the other. We go from moles of C3H8 to moles of H2O. We do that using the coefficients. Those are the numbers in front. Now we're in moles of H2O, we can get to grams of H2O, saying that we have hydrogen by using the molar mass of H2O. We have 2 hydrogens at 1.01, and we have 1 oxygen at 16.00. So 2 times 1.01 is 2.02, and 1 times 16 is 16.00. Add those together, and it comes out to be 18.02. That means 18.02 grams of water is equal to 1 mole of water. Alright, so from here we can use our starting point of where our arrows begin, or the number that's actually in the question itself. 5 grams of C3H8 over 1. We have grams of C3H8 on the top. That means I want to put grams of C3H8 in the bottom of the next one. In order to get from grams to moles, I have to use the molar mass. That's the 44.10. That is equal to 1 mole, so that's going to go on the top of that bracket, of that line. Alright, in the next division, we have C3H8 on the top, so that means I want to put that on the bottom of the next one. Whatever's on top needs to be on the bottom of the next one. And we are right here in our plan. Notice that we're going to use coefficients. That's 1. We're going to water. So we're going to moles of water. And that coefficient is 4. We are in moles of water now. So I want to put moles of water on the bottom of the next one. Look at our conversion factor, and 1 goes with water. 1 goes with moles. That is equal to 18.02 grams of water, which is why that goes on the top. So it's going to be 5 divided by 44.11 times 4 times 18.02. That comes out to be approximately 8 grams of water. I want to point out something in number 6 before I stop the video. I wanted to point out that my theoretical yield of beryllium chloride was 10.7 grams. Well, they didn't actually ask you a question, they just simply told you what the yield was. And so we are not going to do that one in the videos. That's one that you're just going to skip over. And we will come back to the videos at question 7.